Hello students, welcome back to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now let's solve this problem from engineering dynamics. And the problem says that the position of a particle is given by s of t. So s equals to 2t to the power 3 minus 40t square plus 200t minus 50, where s is in meters and t is in seconds. Plot the position, velocity and acceleration as a function of time for the first 12 seconds of the motion. Determine the time at which the velocity is 0. Now we have a particle which is moving along a horizontal line in a horizontal direction. It is moving back and forth, and the position of that particle is given by this equation. So we can say that s of t is equal to 2t to the power 3 minus 40t square plus 200t minus 50. Now we are asked to plot the position, velocity and acceleration. So this is the position function. If we plug in various values of t, we will be able to find the position of a particle at various t values. So if we start putting t equals to 0 in this equation, we will have minus 50. So the initial position of the particle at t equals to 0 will be minus 50. So we can make a table like this, and then using those values we can plot the graphs. So as you guys can see, at t equals to 0, the s of t is minus 50. Now when we put t equals to 1 in this equation, we will have 112 meters. And similarly, putting all the values from t equals to 0 until t equals to 12, we will get all these values. Using calculator, you guys can put various t values in this equation, and we will be able to make this table. Similarly, to plot the velocity curve, we need to have the velocity as a function of time, and as we know that the velocity as a function of time will be equal to d. If we take the derivative of s of t function with respect to t, so we can say that d divided by dt s of t. So we need to take the derivative of this s of t function. So the derivative of this will be, we can say, 60 to the power 2 minus 80t plus 200. So this will be the velocity as a function of time. And similarly, if you want to write the acceleration, so the acceleration will be, we can say acceleration as a function of time will be equal to the double derivative of s of t function, or we can say that dv of t divided by dt, or we can say d square s of t dt square. So if we take double derivative of this, or if we take one derivative of this, then we will be able to find the acceleration as a function of time. So now if I take the derivative of this, we will have 12t minus 80. So now if we put various values of t in this equation, we will be able to find, we will be able to tabulate velocity as a function of time. So this is s dash t. So we can say that velocity of t is the first derivative of s of t, and acceleration is the double derivative of s of t. So now as you guys can see, if I put t equals to 0 in this equation, we will have 200. So when t equals to 0, the velocity is 200 meter per second. And similarly, if we put t equals to 1, we will have 126 meter per second. And similarly, putting all these values, we will be able to have this velocity as a function of time. And similarly, if we put t equals to 0, then the acceleration is minus 80. So this is minus 80 meter per second square. And putting t equals to 1, we will have minus 68 meter per second square. And similarly, at t equals to 12, we will have 64 meter per second square. So if we find all these values, then we can easily tabulate, we can easily plot the graphs of the position, velocity and acceleration as a function of time. So for t equals to 0, the s of t is minus 50. So you guys can see this is minus 50. For t equals to 1, this is 112. So somewhere here is 112. This is 112. So plotting all these values and then joining all those points will give us the s of t, v of t, and the acceleration is a function of time. Similarly, the problem says that determine the time at which the velocity is 0. So if you want to, we want to find t at which the velocity is equal to 0. So if we equate the velocity as a function of time, equation equals to 0, if we say, so we can say that we will be able to find that t. So we can say that 6t square minus 80t plus 200, this is equal to 0. So we need to find the roots of this quadratic equation. So we can say that t will be equal to, if we use the quadratic formula, so we can say that t will be equal to minus b plus minus b square minus 4ac divided by 2a. A is 6, b is minus 80, and c is 200. So we can say that this is minus into minus 80 plus minus, now minus 80 square minus 4, a is 6, c is 200 divided by 2 into 6. So this will give us two values. One is for plus, one is for minus, right? So we can say, let me find the plus values. We will have minus into minus 80 plus square root and minus 80 square minus 4 into 6 into 200, and this gives me 2 into 6 is 12. So for plus we got t equals to 10 seconds, and now if I modify this quadratic formula for the negative, so we will have, here we will have minus b, here we will have minus. So the second value is 3.33 seconds. So at t equals to 3.33 seconds and at t equals to 10 seconds, the velocity is equals to 0. So now you guys can see that at these two t values, the velocity values will switch signs. So as you guys can see that at t equals to 3, the velocity is positive, and at 3 equals to 4, the velocity is negative. So in between 3 and 4 seconds, the velocity is equals to 0. So you guys can see that at t equals to 3.33 seconds, the velocity is 0. And similarly, at t equals to 10, the velocity is 0, as you guys can see here. And similarly, as we know that this is s of t function, the red one is s of t, and on the x-axis this is time t in seconds, and on the y-axis I have plotted all the three graphs, right? So the red one is s of t, the green one is velocity as a function of time, and the orange one is the acceleration as a function of time. So you guys can see that the acceleration is straight line and the y-intercept is minus 80. So this is minus 80, and the slope of the acceleration as a function of time graph is 12, right? So if we find the slope of this acceleration curve, this slope will be 12. So and as we know that the velocity as a function of time is the values of slopes at various values for s of t function. So wherever the velocity value is equal to 0, the tangent to the s of t graph will be having a slope equals to 0. And similarly, as you guys can see that acceleration as a function of time is the derivative of the velocity function. So the acceleration is equals to 0 somewhere here, and then at this particular point, the tangent, the slope of the line tangent to this velocity as a function of time is equals to 0. Now as you guys can see that this blue line actually represents the velocity values. So the slope of this particular line will give us the velocity values. So you guys can see if at t equals to 0, this is the tangent to the s of t function. This red one is s of t. So you guys can see that this line has a slope of 200, which is shown here. And similarly, from the table we can see that at t equals to 0, the velocity value is 200. So the slope of this line is 200 when in t equals to 0. Similarly, at t equals to 1, the slope is, or we can say that the velocity value is 126. So at t equals to 1, the velocity value is 126. You guys can see the green curve shows us the velocity values, and those values are the slopes of this blue line. So at t equals to 2, the velocity value is, or we can say that the slope of this line is 64. So somewhere here is 64, you guys can see. And similarly, if we go forward at t equals to 3, the slope is 14. So at t equals to 3, somewhere here is 3, the velocity value is 14. And now at t equals to 4, the velocity value is negative. You guys can see that this green graph has crossed this x-axis, or we can say the t-axis. And between 3 and 4, the slope of this line becomes negative, right? So before this point at t equals to 3, this slope is positive, and t equals to 4, the slope becomes negative. So somewhere between t equals to 3 and 4 seconds, the velocity is 0, and that particular point, as we know, that at t equals to 3.333, the velocity value is 0. You guys can see from here. And similarly, as we know that the tangent lines to the velocity graph always gives us the acceleration value. So now if I move this tangent line to this, so let me change this, this will become, now again, as you guys can see that now that this line, this blue line, which is the tangent to this velocity function, the green one, so now you guys can see that the slopes of this line will give us the acceleration values. So now at t equals to 0, the slope is minus 80. You guys can see this is the negative slope. And similarly, if we move forward at t equals to 2, the slope is still negative and the acceleration value is negative. So until this particular t, acceleration values are negative. So until this particular point, the slope of this blue line will be negative as well. So this, you can see, it's negative, negative, negative. It's also negative. And then after this point, the acceleration value become positive, and then the slope of this line will become positive as well. So this is now positive. So now from here, at this is 6.2, this is 6.4, this is 6.8, right? So after 6.2 and before 6.4, the acceleration is 0. So here you guys can see that these are the acceleration values. So somewhere between 6 and 7 seconds, the acceleration changes the sign, and similarly the slope of the line of this tangent line changes the value as well. So at t equals to 6, the slope of this line, which is the acceleration, is negative, and at t equals to 7, the slope of this line, which is the acceleration value, becomes positive, and similarly so on and so forth. So I hope you guys would have understood this concept, and this is the solution of this particular problem. The velocity at t equals to 3.33 seconds is equal to 0, and the velocity at 10 seconds is equal to 0. And if someone asks that what will be the value of t at which the acceleration is equal to 0, so we can substitute, we can equate this equals to 0, and then we can find the t value. So that will be between 6 and 7 seconds. So we can say that 12t minus 80 is equal to 0, and we can say that this will be 80 divided by 12. So we can say that 80 divided by 12 is 6.67, or we can 6.667 second. So at this particular point, the acceleration is equals to 0, and before and after this t value, the slope of that tangent line to the velocity graph will switch direction. So that will be negative and then will become positive. So this is the solution of this particular problem. I hope this will help you in your learning. Let me know in the comments if this helps. Do subscribe Engineers Academy for the solution of such more problems from Engineering Dynamics by Meriam and Kraige.